Hello students, welcome to the next lecture on the complex analysis. Today I will explain you the concept of the trigonometric functions. Myself Dr. Harish, you can follow and subscribe my YouTube channel. What we have discussed in our last lecture, we have learned the idea of the exponential functions and discuss its various properties. If you really want to interested to learn more about the exponential functions, follow my playlist complex analysis and you can see the elementary functions, analytic functions and many more lecture available free of cost to all of you. In this lecture, I will explain you the concept of the trigonometric functions. So first of all, we all know whenever x is my real number, then we can define the exponential e raised power iota x is cos x plus iota sin x. What will happen if you add these two expressions and you can subtract these two expressions, you can get the value of the sin x and cos x. Based on the definition of this sin x and cos x, whenever x is my real, we can formulate the definition of the sin of z and cos of z whenever z is my complex number. The first definition arises in the case of the trigonometric function is how you can define the sin z and cos z. Based on the properties of the sin x and cos x, I can define the value of the sin z and cos z. Based on this definition, the first question arises is whether this sin z and cos z are analytic or not. How you can check about the analyticity? We have to define the CR equations, Cauchy-Riemann equations, and check whether they will satisfied or not. Otherwise, second way is we all know e raised to power z is analytic functions that we have discussed in our last lecture. And what will happen if e raised to power z is analytic, then e raised to power z, e raised to power minus of iota z, both are my analytic functions or called as the entire functions. Once the two functions are my entire, then the linear combination is also entire function. Therefore, from equation number 1 and equation number 2, we can say the cos z and sin z are also entire functions. Once the functions are my entire, then we can define their derivatives. For example, how you can define the derivative of the sin z? I can derivative the equation number 2 with respect to z. 1 over 2 iota is outside. It is iota e raised to power iota z minus minus plus iota e raised to power minus iota z. I can divide by 2, then it is iota z plus e raised to power minus iota z divided by 2. That becomes cos of z. Therefore, derivative of the sin z becomes cos of z. Similarly, you can prove that the derivative of the cos z becomes minus sin of z. That is the first property or the first relation between the sine and cosine. Second one is, what are the various properties of the cos z and the sin z? We all know what are the various properties means. We all know in the real analysis, sin x, cos x, both are my bounded functions. Fine. Both are my periodic functions. Fine. And we can apply the value of the sine of a plus b, cos of a plus b, cos of a minus b, and so on. Fine. Now, our target is to check, can we say sine and cosine are my bounded? Whether they are my bounded. Fine. Whether they are my periodic. Fine. Or whether we can apply the formula of the cos of z plus a plus b, cos of a minus b, and so on. The first property that we have defined, we can define the value of the cos z where z is x plus iota y. Fine. So I can prove the first property. I can substitute the value of the cos of a plus b. Now there are the two methods. Firstly, I will tell you the first method. What is the definition of the cos of a plus b? Which is cos a cos b minus sin a sin b. Fine. And by using the property of the cos iota x, that becomes cos hyperbolic x, sine iota x, that becomes iota times sine hyperbolic x. So I can substitute the value, that becomes cos x cos hyperbolic y minus sine x. What is the definition of the sine iota y is iota times sine hyperbolic y, and that's the proof of the first property. Similarly, you can prove the property of the second. This is the first method. Second method is, instead of applying this property, I can start with the definition. Find what is the definition of the cos of z. It is e raised to power z plus e raised to power minus z divided by 2. So I can start with z becomes x plus iota y. Fine. I can write it clearly, e raised to power iota into x plus iota y plus e raised to power minus iota into z divided by 2. I can open the bracket. It is e raised to power iota x, e raised to power minus y. So e raised to power x plus, similarly this is e raised to power y minus iota x divided by 2. Fine. Now you can see I can take half is outside. I can separate them, e raised to power minus y. Then it is e raised to power iota x. What is the e raised to power iota x? Cos x plus iota sin x. I can substitute cos x plus iota sin x. Plus I can apply for the second part, e raised to power y is a e raised to power minus iota x cos x minus iota sin x. Fine. Now you can take the pair, cos x is common, then the inside term is e raised to power minus y plus e raised to power y divided by 2. Similarly, I can take the sin x is a common. Fine. Now we all know what is the expression of sine hyperbolic x cos hyperbolic x. Sine hyperbolic x becomes e raised to power x minus e raised to power minus x divided by 2. Cos hyperbolic x is e raised to power x minus e raised to power x divided by 2. And you can see both are my positive, divided by 2 becomes cos hyperbolic, e raised to power y minus e raised to power minus y divided by 2. That becomes the expression of the sine of hyperbolic y. Therefore, the first result holds. Similarly, you can prove the second part, sine of z, by using the similar definitions. Second property, for any complex number z, the sine complex conjugate of the sine z is equal to sine of the complex conjugate. Fine. So I can start with the definition of the sine of z and take the complex conjugate on the both side. So what is the complex conjugate of the sine z? It becomes negative हो जाएगा. Fine. Now again I am using the same property. What is the cos of iota x? Cos of iota x will be cos hyperbolic x, and sine of iota x becomes iota times sine hyperbolic x. So I can use the same definition. It's a sine of x. I can write cos of iota y minus cos of x. Fine. And I can write iota into sine hyperbolic. Based on the definition, I can write as a sine of iota y. Now it's a sine a cos b minus cos a sine b. That becomes sine of a minus b. What is the x minus iota y? X minus iota y becomes complex conjugate of the z. Therefore, the first property hold. Similarly, that property you can prove it by own and let me know in the comment box. Next property, sin z and cos z are my unbounded functions. Make sure students, we all knows whenever x is my real, we all knows sin x and cos x both are my bounded functions. Fine. That is bounded between 0 and 1. But whenever they are my complex numbers, then we can say sine and cosines are unbounded functions. The proof is a very simple. I can start with the definition of the sine z. Fine. Now we can start with the modulus value. We all know whenever z is x plus iota y, what is the modulus of the z? Modulus of the z becomes square root of x square plus y square. Then I can substitute x is my real component, which becomes sine square x cos hyperbolic square y plus imaginary part cos square x sine hyperbolic square y. I can substitute the value of the sine, all the terms in terms of the sine, by using the property of the hyperbolic. Cos square hyperbolic minus sine hyperbolic square, which is equal to 1. So I can substitute the value of the cos hyperbolic square y, which is 1 plus sine hyperbolic square y. Now you can open the bracket and take the common. So sine square x plus sine hyperbolic square y is common. Inside term is sine square x plus cos square x. Sine square x plus cos square x, that quantity becomes 1. Therefore, the expression becomes sine square x plus sine hyperbolic square y. Now, by the definition of the sine hyperbolic y, that becomes e raised to power y minus e raised to power minus y over 2. Now, what will happen if you take y approaches infinity? Then the value of the sine hyperbolic y will also becomes to the infinity, and once the value of the sine hyperbolic y infinity, therefore sine of z will goes to the infinity, and once this value goes to the infinity, therefore sine of z is my unbounded function. Similarly, you can prove that the cos of z is my unbounded function. So the first difference between, you can say the first difference between the sin x, cos x and the sin z, cos z. The sin x and cos x both are my bounded functions. However, sin z and cos z are my unbounded functions. The one similarity between them is sin x and cos x are my periodic function, while the sin z and cos z are also periodic functions. The proof of the unbounded part we have already defined in terms of the property. However, how you can check whether the sin z and cos z are periodic or not? And if it is a periodic, then what is the period? What is the period? We all know the sine and cos are periodic function with the period 2 pi is my period. Fine. Now what is the period of the sin z and cos z? So I can define the properties of the periodic. Remember student, for any function fz, what is the meaning of the period? If I say p is the period of fz, what does it mean? What does it mean? That means f of z plus p, which is equal to f of z. That's the definition of the periodic function. Fine. That's the definition of the periodic functions. So where f is my sine or cosine. So let's start with this first property. I can apply the definition of the sine z. Always remember, it is e raised to power iota z minus e raised to power minus iota z divided by 2 iota. The first conclusion that we can define, in order to understand the periodic or period of the sine, we must know what is the period of the e raised to power z. Fine. तभी तो समझ में आएगा ना. Okay, and what is the period of this exponential part? That we already discussed in our last lecture. The period of the exponential part is 2n pi iota. That means e raised to power z plus 2n pi iota is e raised to power z. Fine. So now if you look about that, if I substitute z plus 2n pi only, iota नहीं लिखा मैंने यहाँ पे, why? Because e raised to power iota z, already iota है आपके पास. So if you substitute the value, so what will happen? It is e raised to power iota into z 2n pi minus e raised to power minus iota z plus 2n pi. Now if you open this bracket, it is e raised to power iota z plus 2n pi iota minus iota z plus 2n pi iota divided by 2 iota. Now by using the equation number 1, e raised to power, I consider this is my z plus 2n pi iota, which is my e raised to power z. This number is my e raised to power minus z divided by 2 of iota, and this is the expression of the sine of z. Therefore, z plus 2n pi becomes sine of z. What does it implies? This implies 2n pi is the period of sine of z. Similarly, you can prove that the period of the cos z is 2n pi, where n is the any integer. Integer means is a positive or negative both. That means 2 pi, 4 pi, 6 pi, and so on. On the other hand, it is a minus of 2 pi, minus 4 pi, and so on. All are my period of the functions. Fine. The period of the tan of z is my n of pi. Again, n is my integers. The number 2 pi is called as the primitive period of the sine z and cos z. The one important property here is, this is a very important property. This is the very important property is, we call as the fundamental period whose imaginary part is greater than 0. Let's say if I say 2n pi iota is my period. Let's assume that. Fine. So if I substitute the value, that becomes minus 6 pi, minus 4 pi, minus 2 pi, plus 2 pi, 4 pi, and so on. Now look at the definition. Whose imaginary part is greater than 0. What is the imaginary part? Imaginary part of the p is 2n pi. When it will be greater than 0? It will be greater than 0 when n is my positive. Fine. So that means these parts. And out of all these periods, 2 pi, 4 pi, 6 pi, and so on, which one is the smallest number or nearest to the 0? 2 pi. So that's why 2 pi is called as the fundamental period. अभी बहुत सारे एग्जांपल्स आएंगे इसके बाद, उसमें एक्सप्लेन करूंगा डीपली. Next one is the zeros. What is the definition of the zero? Zero means zero of the function fz. So that means our target. What is the zero means? Our target is to find the value of the z such that f of z is 0. That's the meaning of the period of the, or that's the meaning of the zeros of the functions. So our target is to find the period of the cos z and sin z. When it will be the 0? Sine will be 0 when it is n pi. This implies z is equal to n pi is the zeros of the functions. Similarly, cos value will be 0 when it will be 2n into 2n plus 1 into pi by 2, where n is my integers. Therefore, the zeros of the cos z is 2n plus 1 pi by 2. Zeros of the sin z is n pi. Now let's start with the various numerical examples. उम्मीद करता हूं वीडियो को लाइक एंड कमेंट जरूर करेंगे. First of all, your target is to find the zeros and then period. As per the definition of the zeros, our target is to find the value of the z such that the value of the cos 2 iota z plus 13 is equal to 0. That is my target. Fine. And we all know the value of the cos z will be 0 when this number will be 2n plus 1 pi over 2. Why? Because cos value 0 becomes whenever 2n plus 1 pi over 2. So can you find the value of the z from this expression? 2 iota z becomes 2n plus 1 pi over 2 minus 13. I can divide it by 2 iota on the both side. So 1 over 2 iota into 2n plus 1 pi over 2 minus 13. I can rationalize them because iota can never be in that denominator. So it's a minus iota over 2 into 2n plus 1 pi over 2 minus 30. And that's the zeros of the given where n is my integer. Fine. How you can define the period? So let's say, I can say P is the period of the fz. What does it implies? That implies z plus p is equal to f of z. I can substitute the value of the z plus p. That becomes cos 2 iota z plus p plus 13, which is equal to cos 2 iota z plus 13. Now you can open this bracket. That becomes cos 2 iota z plus 13 plus 2 iota p, which is, अब यहीं पे मैं आपको फंडामेंटल पीरियड का मतलब समझाऊंगा आपको. 2 iota z plus 13. Fine. Now, based on this, we all knows the period of the cos z. What is the period of the cos z? We have defined is 2 and pi. What is the meaning of the period of the 2 and pi? That means cos z plus 2 and pi, which is equal to cos of z. Now look at the same. If you consider this number is my z, fine. This number is my z, and if you compare them, what will happen? 2 iota p must be equal to 2 and pi. यही तो आएगा ना, by the definition of the period of the, because cos and sin z are my periodic functions. So therefore, you can say that 2 iota p is my 2 n pi. So can you find the value of the p? P will be minus n iota. Fine. क्यों? क्योंकि आप इसको 2 iota से डिवाइड करोगे दोनों तरफ, then it's n pi over iota. You can rationalize them. Your answer will be n pi iota. Fine. But आपको remember, फंडामेंटल पीरियड में पीरियोडिक फंक्शन को आपको क्या करना है? हमेशा ही पॉजिटिव बनाना है. Fine. Here n is my integer. So I can take p is equal to m pi iota, where m is equal to minus of n, which is also the part of the integers. Fine. So m pi iota. So can you find the fundamental period? Now what is a fundamental period? Fundamental period is whose imaginary part of the period is greater than 0. So what is the imaginary part is? M pi. So when it will be greater than 0? When m is my positive. So what is the fundamental period? M is the integer. The smallest period will be my m is 1. So that is a pi is my fundamental period. Because integer सबसे पहले क्या आएगा आपके पास? 1 ही आएगा. So m is my 1. That is a pi is my fundamental. Pi iota is my fundamental period. और primitive period जो आपके पास, because उसके अंदर पॉजिटिव नेगेटिव जरूरी नहीं है. So whatever the period n pi iota, n is a 1 is the right answer of the problem. चलिए look at the now. The second example is related to the zeros and period of the sine. Again we can start with this. When it will be 0? When it is n pi. That implies iota z plus 2 is equal to n pi. So can you find the value of the z? Iota z becomes n pi minus of 2. So I can find the value of the z is 1 over iota n pi minus 2. I can rationalize them. It is minus iota n pi minus 2. Or either you can take minus as a common. You will get as 2 iota minus n pi iotas are the zeros of the functions. Similarly, we can define the period. We can start with the definitions. I can substitute the value of the f. It is iota into z plus p plus 2, which is equal to sine of iota z plus 2. I can open the bracket. It is sine of iota z plus 2, And by using the definition of the periodic functions, sine of z plus 2n pi is sine of z. That means this is my z, this is my z. So iota p is my 2n pi. So can you find the value of the p? P will be divided. So I can rationalize them. Minus 2n pi iota is the period of the functions f, z. Again, n is my integer, so I can take it as a m. So 2m pi iota, where m is my minus ni. So the fundamental period is, when you take m is my 1, 2 pi iota is my fundamental period. Look at the second one. Third one, find the zeros and the period of the functions. So let's start with the firstly zeros. That implies z minus 2 iota is 2n plus 1 pi over 2. So can you find the value of the z? Z becomes 2 iota plus 2n plus 1 pi over 2, where n is my integer. These are the zeros of the function. For the period, I can start with this definition again. I can substitute z minus 2 iota, which is equal to cos of z minus 2 iota. I can rewrite the given statement. It is z minus 2 iota plus p, which is equal to cos of z minus, because cos of z is a periodic function. The periodic function is my period is 2n pi. Fine. So if you compare them, p will be my 2n pi, where n is my integers. फाइन. अब इसमें माइनस m लिखने की जरूरत नहीं है, बिकॉज नेगेटिव नहीं है. सो व्हाट इज द प्रिमिटिव पीरियड? प्रिमिटिव पीरियड, fundamental period is my 2 pi, because when n is the smallest number, so which is a positive part. Okay, find all the possible solutions of the z. What is the meaning of the possible solution? That means your target is to find the value of the z. Fine. So I can start with the definition of the cos z. What is the cos z? Is e raised to power iota z plus e raised to power minus iota z divided by 2. Fine. You can simplify that. It is e raised to power iota z 1 over e raised to power iota z, which is equal to 4. You can rationalize them. That becomes e raised to power 2 iota z minus 4 e raised to power iota z plus 1 is equal to 0. Now you can see that number is my quadratic. So I can find the roots is e raised to power iota z is minus b plus minus b square minus 4a into c divided by 2a. So that becomes 4. This number is my 16. 16 minus 4 is 12. And what is the root of the 12 is 2 root 3 divided by 2. So that part is 2 plus minus root 3. Fine. So therefore e raised to power iota z is e raised to power iota z is 2 plus minus root 3. Fine. Now how you can compare them? So ये exponential वाला part हो गया. तो इसके लिए आपने ये last lecture जो हमने करा था, that is a exponential functions. तो क्या करेंगे? You can write this quantity in terms of the polar form. Fine. कैसे लिखा जाता है polar form? Whenever you have x, z is x plus iota y, I can write the z in terms of the polar e raised to power iota theta, where r is root x square plus y square and theta is my principal argument. Fine. Which is defined as tan inverse y over x, based upon that whether it lies in the first quadrant or the second or third or fourth. In this case, what is the x? That is a real component. What is the imaginary component? 0. तो अब ये किस क्वाड्रेंट में लाई करेगा आपका? x is root ये y 0, तो ये लाइज इन द फर्स्ट क्वाड्रेंट, एंड फर्स्ट क्वाड्रेंट में आपका एंगल कितना होगा? 0. आप यहां से भी निकाल सकते हो. व्हाट इज द y? tan inverse 0. tan inverse 0 is my 0. r is again 2 plus minus root 3. Fine. So I can write in the polar form So I can write this value is 2 plus minus root 3 e raised to power, because iota 2 and pi is the period. Fine. I can open this bracket. E raised to power y is a separate, e raised to power iota x is separate. Now you can equate the coefficients. What is the real part? This is the coefficient of the exponential. E raised to power minus y is 2 plus minus root 3. And if you compare the second part, x becomes 2 and pi. Fine. And you can find the value of y. Y becomes log of, minus of y becomes log of, and y is here. Therefore, your solution x plus iota y, I can substitute the value of the x plus iota into y. Y is my minus log of 2 plus minus root 3. And that is the answer of this problem. Now, can you find all these 8 questions? Can you find the primitive period of the functions? Can you find the periods and the zero of these 4 parts? You can do it by yourself and let me know in the comment box if you are able to solve it easier manner. I will upload the next part on the hyperbolic functions very soon. Till then, you can share this video, like and comment on this. Happy learning, students. Best wishes. Thanks for the watching.